Welcome to SND College of Engineering and Research Center Yeola, Department of Applied Science online lecture series. This lecture depends on first year engineering or subject engineering physics, unit first wave optics. In the previous video we have already learned interference and diffraction. Today we will discuss about Fraunhofer diffraction at n parallel slits, means number of parallel slits. A plane diffraction grating is an arrangement of a large number of close, parallel, straight and transparent and equivalent slits, each of equal width, neighboring slits being separated by an opaque region of width. On a plain glass plate, fine lines drawn by diamond pen. The spacing A plus B between center of an adjacent slit is known as grating element. Therefore, number of slits n is equal to 1 upon A plus B line per centimeter. Arrangement of large number of parallel slits placed close to each other and separated by equal opaque spaces between them. If A is the width of the slit, that is space between the lines, and B is the width of the line, that is width of opaque space, then A plus B is called as grating element. If there are n lines per centimeter, then NA plus NB is equal to 1 centimeter. Therefore, grating element is A plus B is equal to 1 upon n centimeter. On the screen you have to see diagram S1, S2, S3, S4, S5 and Sn. Therefore, angle generated is theta, P1, P2, P3, P4, P5 and Pn, and P and P0. Consider plane diffraction grating having n number of slit, each of a width A, separated by opaque space. The distance between center of the adjacent slit A plus B is known as grating element. When a plane wavefront of a monochromatic light incident normally on a grating, every point in each slit acts as a source of secondary wavelets and send it all directions. The ray which diffracted through an angle theta incident at point P on screen, and now we want to calculate resultant intensity at point P. The phase difference between S1 to P1 and S2 to P2 is equal to S2 K1 is equal to A plus B sin theta. Then E theta is equal to AM sin alpha upon alpha. Therefore, alpha is equal to pi upon lambda A sin theta. Then corresponding the phase difference between the light rays coming out adjacent slit is minus A plus B sin theta. Corresponding phase difference is pi is equal to 2 pi upon lambda A plus B sin theta is equal to 2 beta. Using vector addition, resultant amplitude of n waves coming out n slits can be found out, and it is obtained by E theta is equal to Em sin alpha upon alpha sin n beta upon sin beta. Intensity is given by I theta. Intensity is given by I theta directly proportional to Em raised to 2 sin square alpha upon alpha square sin square n beta upon sin square beta. The factor Em square sin square alpha upon alpha square gives intensity distribution due to single slit, and the factor sin square n beta upon sin square beta gives intensity distribution due to n slits. Therefore, intensity I theta directly proportional to Em square sin square alpha upon alpha square sin square n beta upon n square beta. The resultant intensity is given by I theta is directly proportional to Em square sin square alpha upon alpha square sin square n beta upon beta sin square beta. Next, condition for principal maxima. The principal maximum due to the effect of n slits is obtained when sin n beta upon sin beta is maximum. That is when sin beta is equal to 0 or beta is equal to plus minus m pi, where m is equal to 0, 1, 2, 3 up to infinity. But then sin n beta upon sin beta is equal to question mark. Limit beta tends to plus minus m pi. Sin n beta upon sin beta is equal to limit beta tends to plus minus m pi d sin n beta upon d sin beta is equal to sin beta tends to plus minus m pi n cos of n beta upon cos beta is equal to n cos plus minus n m pi upon cos of plus minus m pi is equal to plus minus n. Therefore, limit beta tends to plus minus m pi sin n beta upon sin beta bracket square is equal to n square. Thus, for beta is equal to plus minus m pi, then I theta intensity directly proportional to n square em square sin square alpha upon alpha square. Then condition for principal maximum beta is equal to pi upon lambda a plus b sin theta is equal to plus minus m lambda, that is a plus b sin theta is equal to m lambda. There are n minus 1 minima between two principal maxima. There are n minus 2 secondary maxima between two principal maxima. Condition for minima: when we get minimum sin square n beta upon sin square beta is 0, that is when sin square n beta is equal to 0, n beta is equal to plus minus m pi, then m is equal to 0, 1, 2, 3 up to infinity, but m is not equal to 0 and 2n, that is n into pi upon lambda a plus b sin theta is equal to plus minus m pi, then n into a plus b sin theta is equal to plus minus m into lambda. On the screen you can see diffraction pattern of Fraunhofer diffraction at n parallel slits. For n is equal to 5, first is maximum, then minimum, 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 again maximum, minimum, 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 maximum. So student, I hope you have understood this. Thank you.